Problems 8 and 9 are also both compound inequality problems. They're getting a little more challenging, but they are still solvable. Number 8, because there is only one variable, I can draw my 2 lines and just start solving. The first thing I want to get rid of is this denominator. It's dividing by 9, so to undo that, I'm going to multiply by 9 in all sections to get rid of that. Negative 27 is less than 6 minus x, which is less than positive 27. The next thing I need to get rid of is isolating that x. So I have to get rid of the 6. I'm going to minus 6 in all sections. So I have negative 33 is less than negative x, which is less than 21. Now at this stage, we are not done because this x is still negative. Remember in class, we've discussed that if there's a standalone negative, it's like a number -1 is sitting there. I need to get rid of that -1 to get x alone. So I can divide each section by -1. In doing so, I have positive 33. Remember, you have to flip your sign, so is greater than x, which is greater than -21. Here is my final answer. And then number 9. Number 9 we did discuss a little bit. This time we have more than one variable. When you have a problem where we have multiple variables, so I have an n here, I have an n here, and I have an n here. I have multiple variables in that problem. I cannot solve that like I solved number 8. Instead, what I have to do is I have to break it apart into 2 pieces. I have to take my first piece, 5 plus 2n is greater than or equal to 2 plus 3n. And then have my second piece, which is this part here. And 2 plus 3n is greater than 6n minus 2. I have to break it apart into those 2 separate inequalities that I am solving, and then remind myself that in the end, when I have my final answer, it's an and statement. I just have to break it apart to solve because I have multiple variables. So when I solve the first half, it's just regular solving. So I'm going to minus 3n on both sides. I have 5 minus n is greater than or equal to 2, minus 5 on both sides, minus n is greater than or equal to -3. And as we've discussed, in front of that n is really a -1. So to get rid of that, I have to divide by -1 on both sides. And when I do so, flip my sign. N is less than or equal to 3. And now I have to find the second half of my answer, which is the second half of that inequality that I separated. Minus 6n on both sides. So I have 2 minus 3n is greater than -2, minus 2, -3n is greater than -4, divide by -3, and I have to flip my sign again, so n is less than 4/3. Now when we solve, you notice that we have a problem. It says n is less than 3 and n is less than 4/3. So how can that be? And so the easiest way to think about this is let's throw it on a number line. 1, 2, 3, 4, 5. So if we have 0, 1, 2, 3, and 4. If n is less than 3, or equal to 3. I have a closed circle at 3 and my arrow is going down the number line. But then this other problem says that n is less than 4/3. So 4/3 is really 1 1/3. So at 1 1/3 I have an open circle and n is less than. Now when it's an and statement, we've always talked about we're looking for the overlap. You'll notice that both of these answers are true starting here and going down. And so when we think about the answer for this problem, we actually can't say it's both. what we can say, though, is that this is true here. So we can say that n is simply less than 4/3. So in this problem, because it is a bit of a challenge problem, first we had to break it apart into the first half and the second half. And then when we solved, we ran into an issue because in both answers, we had n was less than a number. So I had to figure out where is both of those answers going to be a true statement. And the easiest way for me to see that was to throw it on a graph. When I graphed, I saw that both of those make a true statement when n is less than 4/3. So that is our final answer. Simply, n is less than 4/3. We ignore that other half. Moving on to the second learning target, this is your application problems or word problems. The first one says the average price of gas is $3.35. Gas stations are allowed to exceed this price by 10 cents or go under price by 5 cents without losing business or getting in trouble. Write a compound inequality to show how much price gas stations can charge. So when I think about gas at $3.35, I can be over by 10 cents, so I could charge $3.45. Or if it's $3.35, I can be under by 5 cents. So I could subtract 5 cents and be at $3.30. So gas can be anywhere between these values. So when I think about this, the price of gas is X. It can be anywhere between my lowest to my highest. My lowest is $3.30, or all the way up to my highest price of $3.45. So X is the price of gas, and it can be sandwiched anywhere between $3.30 and $3.45. Number 11 says Chuck earns $250 a week plus a commission equaling 3% of his sales. His goal this week is to earn at least $375. Write and solve an inequality. How much must Chuck sell to reach his goal? So he earns $250 a week plus 3% of his sales. So how much does he need to sell? I'm going to say X equals the dollars in sales. And 3% is going to have to be changed to decimal. 0.03 times how much he sells. That's how much his commission will be. And it has to be at least. How much money he takes home has to be more or equal to $375. So right there in orange, we have our inequality. And now we actually have to solve this. So we're solving. We're going to subtract 250 on both sides. So I get 0.03x is greater than or equal to 125. Divide by 0.03. 0.03. And when I solve, I get x is greater than or equal to 4,166.67 cents. So, how much must he sell? He needs to sell, because remember, we have to write the sentence. This is lesson number 2 if you forgot. He needs to sell at least. Remember, this phrase here needs to represent the inequality that you're using, and that has to be in there. At least $4,166.67 in order to reach his goal for the week. And then last, Heidi's SUV gets between 10 and 13 miles per gallon of gas. Her gas tank can hold 25 gallons of gas. If Heidi drives an average of 60 miles per hour, how many hours could she drive? Write a compound inequality to figure this out. So when you see a problem like this, start with the first thing you see. The first thing I see is her SUV gets between 10 and 13 miles per gallon. So I'm going to write this down. I get between 10 miles per gallon and 13 miles per gallon. So how much she ends up being able to drive is going to be sandwiched in between. That's my variable, and it's between 10 and 13. The second thing that I see says her gas tank can hold 25 gallons of gas. So if I can go 10 miles per gallon and I have 25 gallons, so I'm going to multiply by 25 gallons. That's going to tell me how many miles I can go. So, because it's 25 gallons, if I multiply by gallons, then I can know how many miles I'll make it. So if I fill my tank with 25 gallons, how many miles will I end up going? I can go between 250 miles and 325 miles. But there's more information given to us. The next piece of information says she drives an average of 60 miles per hour. So still working off this inequality. If I can go that many miles and I drive at 60 miles per hour, I'm going to now divide by that 60 miles per hour, divide by 60 miles per hour, and in doing so with my labels, that's going to tell me how many hours I can go. So 250 divided by 60 is 4.17 hours, while 325 divided by 60 is 5.42 hours. So now, how many hours can she drive? I have my answer. She can drive between 4.17 hours and 5.24 hours. And here is that final answer.